Okay, so without all the jibber jabber here, just moving right along. B is next. So B is going to be our first product rule. So we see B there, we can write it, but we don't need to. We see it right there. So what is the derivative of that? Multiply both sides by d over dx, and we get one of them. Let's go ahead and write it here. Yes, 1 times the derivative of the other one. What is the derivative of 3x minus 3? It is just 3. Yeah, minus the 1 on the right. Yeah, we could factor out a 3. That doesn't matter. Yeah, times the derivative of that guy, which is just him right there. So we clean it up. We always simplify if we're good at algebra, if we're like algebra whizzes and all that. It shouldn't be very hard to simplify that. We don't care about algebra, but there's more than one way to handle it algebraically. I see that we can factor out a 3x cubed, so why wouldn't we do that? Put the negative on the inside of there in your head. It becomes negative 3x plus 3 is what that becomes. So tucked down way in the corner, I'm getting 3x squared. Yeah, 4 minus 3x, is that right? Yes, so it is derivative review. Literally in this class, people, I mean, everybody's strong with these derivatives, but we could still get people who are at different levels. So we do have to take it a little bit seriously. I don't know, being a video, you can pause it, go backwards. We don't say rewind anymore, but you can pause it and all that in the video. But sometimes also, yes, when I talk, I do make mistakes, but it is 1. Yeah, minus 3x plus 3, that is 4. So in the end, if I can remember, I got this 3x squared. Yeah, 4. I already forgot what it was, but it doesn't matter. Okay, so we had it written in the corner. Let's just move on there. Yeah. So C is going to be him right there. Yes, we have the derivative is that. The derivative of the other one is a chain rule. The power comes out front to the 2 minus 1. The derivative of the inside is 1. Yeah. So minus this one, the one on the right, times the derivative of x cubed. Yeah. Okay, so that is the derivative. Now we just simplify. What do we have? We have 2x cubed. It is x plus 2 to the power of 1. Yep, minus 3x squared, x plus 2 squared. It's always a matter of debate, especially if we set the derivatives equal to 0, which we typically do. It's the whole point is max and minimizing and all that. We don't always simplify these things. It's not always necessary, but uh, it's derivative review is also algebra review. The more we go back in time, the just sillier. We really shouldn't have to review algebra, but some people do. So I'm seeing that I can factor out an x cubed and an x plus 2. Yeah. You can't factor out an x cubed. What do they share? You can factor out an x squared and an x plus 2. We can factor out an x squared and an x plus 2. That's what I'm seeing. We don't care how we simplify as long as we do. We should be able to exercise some nifty algebra. So if we take out x squared, x plus 2, I see that we have a 2x left minus 3. That's x plus 2 to the power of 1. We have x plus 2 left. It's x squared, x plus 2, 2x minus 3x minus 6. Yep, x squared, x plus 2. Yes, it would be negative x minus 6. We don't always quite like how these things look, yeah. So we could factor out a negative there. So negative x squared, x plus 2, x plus 6, where I just factored out a negative. That one right there is what I am getting for C. Yeah, let's just kind of pause it there for a second. And then, of course, we move on. Yep. So moving right along, D. So just every new idea, it's calculus 1 and it's some algebra. Every kind of new, very, very small review idea that comes along. What are we talking about for D? We're talking about the obvious fact. This is not the derivative. This is the function. We're talking about the obvious fact that when you take a derivative, all radicals are written as exponents. We really aren't going to do any algebra review. That's stupid. But a square root is a 1/2. A cube root equals x to the 1/3. Yep. Fourth root equals x to the 1/4. And it does go on to infinity. We're just going to erase this because it's so silly. But what do we say? The nth root equals x to the 1/n. Yep. I mean, there's a basic algebra rule there. So we didn't need that, but I just wrote it because I felt like it. So back to the point, D is f of x equals x squared. It is x minus 1 to the 1/2. And it's all of the above. It's a product rule and it's a chain rule. So the derivative, multiply both sides by d over dx, is the left times the derivative of the one on the right. We always skip algebra steps. It is 1/2 minus 1. So 1/2 minus 2 over 2, if we squeeze that in there, times the derivative of the inside, which is just 1. The left times the derivative of the right, plus the right, yes, times the derivative of the left. I know that I can't help but say it over and over, but not here. It's not part of this yet. We do quite often set these equal to 0, which makes the simplifying easier and quite oftentimes not even necessary to simplify. That is the answer, and we don't have to simplify it, but it's just one of those things where we're still supposed to be capable of simplifying. What do we have there if we kind of clean that up a little bit? We have 1/2 x squared, x minus 1 to the negative 1/2. Yeah, plus 2x. Yeah, x minus 1 to the 1/2. Yeah. So we put things over 1. If we want to bring something to the bottom of the function, we should be able to skip that. Yes, but I see x squared over 2. That thing's coming down below is an x minus 1 to the positive 1/2. Yeah. Plus 2x minus 1 to the 1/2 over 1. And yes, if we want to, a bunch of common denominator stuff, we can multiply top and bottom by x minus 1 to the 1/2 to, yeah. So we have to, should be very, very, very easy. Even if it's crazy hard, it should be very, very, very easy to do common denominator stuff. Yeah. If that's the bottom of the fraction, I did not mean to erase that. If that's the bottom of a fraction, you multiply top and bottom by that, and now we have the common denominator. Yeah, what is x minus 1 to the 1/2 times x minus 1 to the 1/2? It's x minus 1 to the 1/2 plus a half, which is x minus 1 to the 1. So we have things like that everywhere. Yeah.